All right, so for this bell work, we are just trying to find the IQR. Remember that is called the interquartile range. That's where we're looking at. We have our max right here. This is the median. This is the min. Just a second. So we have Q3 right here and Q1. So all we want to do is take Q3 minus Q1 to get the interquartile range. So I'm seeing that this is, I didn't draw that line very straight. That's about 29. If I draw this over, again, that's not super straight, but that's about 17. So anyways, when you subtract 29 minus 17 gives you 12. So the best answer for this one is 12. I will say we have a lot of answers that are very close. So, well, 12 and 15 are both reasonable answers here. And if there's a question like this, where it's like, what's the best estimate for something? And it shows up on the AP test, typically they're going to give you like more of a space between your answer choices. So this one, it might be like, oh, okay, I just kind of looked at the lines a little wrong and I picked 15, but maybe it should have been 12. But whatever the case, that's what we're looking at for this problem. So hopefully there's no confusion on that. Here's what we're doing today. You will be creating a couple of box plots using your calculator. Hopefully everyone was able to go this weekend or sometime last week to pick up the calculator. If you don't have it, you're going to be a little bit at a loss right now, and you'll need to make sure you get that as soon as possible. All right, you can go back to the school, check in at the front, and they'll let you into the library to go and grab that if you didn't get it before. Okay, so first of all, I know some of you do have calculators at home, and the first thing I want to ask is, I don't know if anyone is using a Casio at home. Does that describe anyone out there? And you can give me some kind of feedback to let me know if you are using a Casio. I'll assume in about 10 seconds that no one is. Okay, no reactions. Okay, that's pretty good. Now these are really great calculators, but we're going to be, okay, someone does have a Casio. There is a website I can share with you. In fact, I will just put it directly in the links right now. Whenever we're doing certain functions on our calculator, you're going to access them differently. I know you have at the top, there's like a mode button, or I don't know. I need to see the keyboard right now to tell you for sure. But you're going to have a different way of doing all the things that we're doing. And so I just sent you a link for that. So for today, you might be a little bit lost, but you can figure it out, hopefully. Okay, we are going to be creating a lot of lists. And unfortunately, I don't have a good way of showing this except for maybe unsharing the screen and just making my screen bigger. But a couple of things that you need to do kind of preliminarily for your calculator. Talking about the TI-84 Plus, the first thing I want you to do is hit the mode button just on the main screen. It doesn't matter. And if you scroll down, you have a bunch of options on the front, but we don't care about that. Go all the way down, almost to the very bottom, and it has an option for stat diagnostics. So if you can find that stat diagnostics, you want to make sure that is on. Okay, I'll just say that one more time. You hit mode, scroll down until you see stat diagnostics and turn it on. And that is one of the things, you just turn it on and it just stays on this entire semester and you don't need to worry about it again. Even if you have to change out your batteries, it should remember that, but you can always go back and find that out. All right. The setup editor. So I guess before we do anything else today, because we are going to be using our calculator to create some lists, the way that you access all your lists is you hit the stat button. And so that's, if you can see where I'm, it's right in the middle top, hit the stat button. This is kind of awkward to show, but the very first one is edit. You just hit enter on that and you have a bunch of lists. There are some things that you might want to know about these, but if you go up to the, again, this is going to be really awkward. I don't know if this is big enough to see in the corner. I might need to unshare for a second so that my screen's a little bigger for you. All right, and I need to make it so you can see what I'm doing. Okay, this is awkward teaching right here. But anyways, you can go, you can see a lot of lists. If you, I don't want to delete that first one, but if I go up, then like, let's say I have a bunch of numbers. I'm going to add some numbers to this one real quick. 8, 5, whatever, I don't care. So I've got this list and I added some numbers to it, but I want to delete it. I want to delete all the numbers out of the list. You can scroll up to where the list name is highlighted and you hit clear. All right, and then it will just say list 2 equals nothing, and then you hit enter. All right, so you cleared it, you still have list 2. But I wanted to point this out at the beginning, and if you need to hear this again, just let me know. If you go up and you accidentally hit delete instead of clear, and I'll just do it real quick, all of a sudden, and you can do that right now if you want, I just lost my lists. So now all I see is list 1 and then list 3, and that looks like a bad thing. But there's a way of getting that list back, so don't worry. So I wanted to show you, I'll just get out of this real quick. So you go back to stat, and down at the very bottom of stat, you see, oh, dang it. All right, that's what I get for trying to, that's what it's like playing guitar backwards over your head or something. Anyways, down at the very bottom, it says setup editor. If you select that, it'll just, run setup editor, you hit enter and it'll say it's done. Now you got your list back. So I just wanted to point that out at the beginning in case you accidentally delete lists. It's not that big of a deal. So now I've got list 2 back. Okay. That was just, again, if you forgot how to do any of that, or you didn't fully follow what I was trying to get you to do, not a big deal. We can go over that another time. Okay. What am I? Okay. There we go. Sorry. Now we're back to this. Those are just some basic setup things. Okay, one thing I forgot to talk about on Friday when we were talking about Disco and how we describe our lists. Another one that, I'll make that a capital S, that we need to remember is we need the context. And so if we're going to say this distribution is, unimodal, symmetric, it has a center somewhere around 50, a spread, a range of, 75 and no outliers. We just went through Disco, but we also need to say what that list, what the distribution is describing. We need to add some context. This is a distribution of weights of dogs. Okay, so something like that. So anyways, we'll try and reinforce that idea. You're going to get so used to using context for everything that I don't think that's going to be too much of an effort after too long. All right, creating a box plot. I'm going to give you a list of values and you want to put them in your calculator. And of course, I'm showing you right now what you're going to do after this, but it's going to be a second before you can do that. So just go to your stat and then edit, and then you can plug these values in. It doesn't matter the order you do it, just make sure that you all those lists or all those values in there. So I will pause and give you some time to do that. So if you already plugged the values in, you might have already looked at this at the top and it says, here's how you can access the 5-number summary. So remember the 5-number summary like we saw in the bell work, the min, the max, the Q1, Q3, and your median. We can get that on the calculator and it does it for us, which makes our lives a little bit easier. All right, so all you need to do, you already know where the stat menu is. You can get out of the lists. You can go to stat. Before you can click anything, you have to scroll over to that top menu right here. You have to scroll over to calc. And it gives you a lot of options, but we only need for right now to worry about the top one variable stats. Our one variable is teacher salaries in the 2017-2018 school year. And it still gives you some more input options. The list we want to pick, that notation there, L1, is talking about list one in your calculator. So you can see at the top, all of them have labels, L1, and you can have others. That's good. We want to use that. I'm assuming you put it there. And then you can just go all the way down to calculate. Don't worry about the next one, frequency list. We will use that one later. Okay, and you got, sorry about that. You got some numbers there, but I want you to scroll down. And if you scroll all the way to the bottom, you're going to see your 5-number summary, your last 5 numbers there. So what I want you guys to do, and you can pick any one of these values. I want you to plot where the min is on this. And the way, when I say plot it, don't like write directly on this number line. So I'm just making up a number. If one of the numbers goes here, just draw a vertical line about like that, where you think, and if you think this is where the median is, you can just label that's the median. So if I could have you guys fill in this table with all the values, I'll clear it real quick. Since your stat plot is already set up to have all of the data in it, and it's already referring to list one, if you add that data point in and construct the box plot one more time, then it'll automatically update and it'll show you what it looks like with that new data point put in. All right. So let me see. I don't think I have you guys draw that again. Yeah, I do. Okay. So I'll just sketch it on there real quick just to make it go a little faster. If I can get to the right place. So now I guess we can show this real quick. I'm going to trace this and I can see the numbers. It's still about 34,871. So that's the min. And then the median, or sorry, the Q1 did change a little bit. Now it's 38,234.5. That doesn't really affect things too much. So I'm going to be about right here. And then I'm going to be at 42,630. That changed just a little bit. Now I'm at 47,563. So that's going to be just about right here. And that's at 5.9. Okay, so that's still going to be just about 60,000. But now I have this little dot right here that's just above 71,000. And so I can create the rest of this box plot. So not much has changed here except our Q1 and Q3 and median. And we added that outlier. But honestly, because it's resistant to outliers, it doesn't change by much. Okay, so that is the way that we can construct this. All right. Now, I guess I should mention that these data points, these are real teacher salaries from 2017-18. And I did want to point out that this one right here is a special case. This is actually the ROTC leader over at Cocoa, because he is both a school employee and he's military. So his salary is set by the military. So it's kind of this weird situation, but anyways, that's why he's the outlier. I will also say that I included my own salary in this list. I'm not going to tell you which one I am, but so 2 of these were not random, but the rest of them were randomly selected. I will tell you, I am not that one right there. That is not me. Okay. So another thing that this whole chapter is kind of about comparing distributions, right? So the easiest way of doing that, I think, is when you have a bunch of box plots, you can really quickly compare, but sometimes they give you multiple histograms to compare them. So what I want you guys to do is, remember on Friday we talked about DISCO just as a helpful acronym. So let's compare the distribution and shape. And so I don't know if you guys have any initial thoughts you want to throw out there. Remember, distribution is it unimodal, bimodal, multimodal? Is it uniform? Also, is it skewed left or right? So if we looked at the histogram on the left, is it, how would you describe that one?
Unimodal and symmetrical.
There you go, unimodal and symmetric, perfect. The one on the right.
Is it skewed left?
Skewed right. It's the direction that the tail goes. So yeah. So there we go. It is skewed right. And what else would, would you describe the distribution?
Is it bimodal?
It's a good thought. This is one where it's kind of tricky when you see it go down and then back up, but I think it would probably still be best classified as unimodal. Because one thing that, of course, is probably obvious to you all already, but we'll talk about is like populations and samples never perfectly fit what you're used to is the bell curve, right? They never perfectly fit a bell curve, but they can be closely approximated by it. So yeah, you might have the actual data does this sort of weird jumble and it goes up and down and even something like that. So that can happen. All right, so we would say unimodal and symmetric on the left, unimodal and skewed right for the one on the right. So we just can compare them. And you'd want to put that into a sentence. If this was a FRQ, a free response question, you'd want to write that in a complete sentence. The histogram on the left is dot, dot, dot. And while the histogram on the right is dot, dot, dot. Of course, there'd be context as well. We'd know what these histograms were about. We want to compare the spread. Now, we could talk about the approximate IQR, the approximate standard deviation, things like that. But knowing nothing about that right now, what would you use to describe the spread?
The range.
Very good. So what is the range for the histogram on the left? This is almost a trick question, isn't it? Anyone have a thought?
Is it like maybe 89 or 90 or so?
There you go. So you're on the right track with that, and that's good. So with histograms, we don't know the exact range because we don't know the actual data points. I know that there's some data point right here that's between 91 and 100, or a few data points, but I don't know the actual values. So that tells me I don't know the exact range. Here's what I can say. The lowest possible value that can be here is 91, and the highest is 100. The highest possible value here is 20, and the lowest is 11. So my range is going to be somewhere between that difference and that difference. So if I do the subtraction there, 91 minus 20 is 71, and 100 minus 11 is 89. So my range is somewhere in that interval, if that makes sense. And that's all we can say right here. And I can tell you the AP readers are not going to be absolute sticklers for getting these exact numbers. At least I don't believe they would be. So if you're like, the range is going to be approximately 70 to 90, then since you have that caveat that it's approximately 70 to 90, you know, that's probably good enough to show that you know what you're doing. And there you go. So we don't need to talk about, it's going to be the same thing for this one over here because we have the same bins that we're comparing. So the ranges are going to be about the same. Not the most ideal, but when we're limited, we can compare the two that way. Okay, the center. Where is the center likely to be for this histogram?
In the 51 to 60 range.
There we go, perfect. And that's all you have to say. I will add this. For this distribution, should we use the mean, x bar, or should we use the median?
The mean.
There it is. For this one, we want to use the mean. And why is that?
Because it's symmetric and unimodal.
You got it. That was kind of a minor point on Friday, but we want to make sure that gets reinforced. So because it's unimodal and symmetric and it looks like this distribution right here, mean is the best choice. Okay, so where is the center of this histogram going to be? Now you could spend your time counting because these are frequencies and figuring it out, but that's not, we don't have to be that exact right here. Any thoughts on the center there?
Would it be like 61 to 70?
Well, it would be closer to the mode, though you are right in the sense that since here's the mode, here's obviously where the peak number of values are. It is going to be, if we're talking about mean, it is going to be pulled to the right, but it's not going to be pulled that far. But again, maybe before we answer that question, should we be using median or mean for this one?
The median.
Median. So where will the median be? All right, it's a little bit, it's hard to know. I hope you guys are kind of going back and forth between these two. Pretty obviously, we got most of the data stacked up on the left side, and maybe you can't decide between those two. And you could get really technical and spend a lot of time and say, oh, that's about 12 observations there. And this is about 45. And this is about 65. And, add it all up and find out where the true median is. That's a good thing to do. If you have the time, it's worth it. We could also just kind of estimate and say, it's not going to be here. I might say it's going to get pulled over one to the right. So I'm going to guess it's in this bin right here. And again, just do things to hedge your bets. Say the center is approximately 40 to 50. All right. And when we say the median for this histogram would be approximately 40 to 50, while the mean of our other one is approximately 51 to 60. So our centers are going to be in different spots. And of course, I guess it's worth mentioning right now, if the mean is right here, the median in a symmetric unimodal distribution is going to be in the same spot, approximately. So the mean and the median should both be about right here. So we could still use the median since we're comparing, we have a median over here. We could compare it to the median on this one. But we could also mention something about, since it's unimodal and symmetric, the mean is the best measure of center. So I'm trying to give you guys ideas of how to describe it without saying there's an exact way you need to say it. All right. So if you want to make sure that you've got a description that works, then we can talk about that. All right. With this one, I'll just quickly talk about it. Neither one of these appear to have any gaps in the data or outliers. And there we go. We just talked about both of them. If it's not there, it's not there. But you want to mention that you looked for it. Okay, now the context. Now this is not the best example in the world because we don't know what this is referring to. Maybe this is referring to the average number of letters delivered per hour somewhere, or packages delivered per hour. I don't know. I'm making stuff up. So all kinds of contexts that you could imagine, and you want to include that in with your description of everything here. So I know it's a little bit ambiguous how we're starting this off, but you'll get some practice. And remember, as you're describing, you can always check the answers in the back of the book to see if your description matches up with what might be expected. Okay, so this is the other thing that we can do for comparing. I will say, and you'll probably agree with me, at least I think you will, that comparing box plots is a little easier than comparing histograms. So we know that each whisker or box part counts as 25% of the data. So which one has the widest range? The people who survived or the people who died?
People who survived.
People who survived. That's a pretty straightforward question. You can see the range given right there. All right, and again, I didn't give full context to this. I was really focused more on the displays in themselves, but you can see that this is probably, I would guess, this is referring to babies and those who survived their infancy and being born and those who died in their infancy. So you can see the birth weight of those who died versus the babies that survived. What percent of the group who died fall below the median of the group that survived?
Is it about like 75%?
You got it. So it's a little bit weird to parse through the language on this. And maybe it takes you a second to wrap your head around, like, wait, what is it asking me to do exactly? But we're saying what percent of the group who died, okay, what percent of this group fall below the median of the other group? So the median of this other group is right here. So I'm just going to draw this line. So what percent falls right here? Well, this is 3 of our quadrants. That is about 75%. And we could write a brief comparison of these two groups. All right, and this is really all we need to see. So we've got, maybe before we write a comparison here, I want to go back to the previous slide, because I could create a box plot out of this distribution. I know that the median is going to be about right here. I'm just going to draw a line. I know that the min and the max are going to be, I'm just going to draw it at the end. I don't know. Now, 50% of the data, I'm not trying to get 100% accurate with this, but 50% of the data seems to be about right here or less. Maybe it's not even that big of a group. Maybe like 50% of the data falls like right there, right? So if I was to guess, I might put a line about right here and a line about right here to say that it looks like if I got that area right there, that would be about 50%. Again, just guesswork. So now that is what a normal distribution, a symmetric unimodal distribution would look like with a box plot. Here we decided the median is going to be, I don't know, somewhere around here. Doesn't matter exactly. There's going to be 25%, so the min and the max. Now the 25% of the data might fall somewhere about right here. And then another 25% of the data might Actually, I'm not even going to go that far over. Maybe about that far. And then 25%, maybe the split's about like that. And I might move this median over just a little bit. All right, because I want to make sure this is very clear. Maybe I'm exaggerating just a little bit. But we can see that it seems like these two quadrants have much smaller range than those two quadrants. So it's showing a right skew. So the box plot themselves, while it doesn't show the full shape of the histogram, it does give us an idea of if it's right skewed, left skewed, symmetric, and so on. So knowing that, we can kind of look at this and we could imagine what the distribution would look like. So the one at the top, it looks almost like it's going to be pretty symmetric, right? This tail doesn't look way longer than that one. This quadrant and this quadrant are about the same. And we get to this point where maybe it's just this kind of a distribution right here. All right, a little bit of a hump in it, but it's not like this box plot would be. Where if I had that, then I would have this big spike in the middle, and then it would tail away. This isn't quite that extreme, so maybe more of just like a subtle growth. And again, if any of this doesn't make sense, we can talk about it more. This one right here, it seems like it's going to go more like that. I don't think I drew that very well. Okay. I don't think I'm fixing it by drawing over it over and over again. So whatever, I'm just going to call that good enough because I don't know I'm going to do better. So this one has a little bit of a tail to it. I should have cut off right there, but there we go. So it's just kind of important to see the relationship between histograms and box plots. All right, enough on that. Now we can kind of compare these two. For the distribution, we actually don't know. We could imagine what the distribution looks like, but we don't really 100% know if this is unimodal and symmetric, because it could be all kinds of weird stuff going on. Like maybe it looks like this. I don't know why it would, but maybe it does. And it just happens to fit about 25% of the data in each block. So we can only be we'll just verbally go through this. So for those that survived, I would say it's symmetric, or it appears to be symmetric and possibly unimodal. All these little weasel words that say that maybe this is true. And among those who died, I would say it's possibly unimodal and most likely skewed to the right. There we go. For the center, or for the spread, I would just talk about the range here. No, I could talk about the IQR. I've got that. So I could compare the IQR of these two, and the IQRs, whatever that comes out to, about 1 for those that survived and a little under 1 for those that died. Anyways, I can talk about that, and it's going to be in kilograms for the unit. For the center, the median, and this is where, since we have the median, we want to use that. The median here is approximately 2.2. The median for this group is approximately 1.6. So we can compare kilograms. So we can compare that way. And lastly, doesn't appear there are any outliers. We would see our little outlier mark if there was. Okay. So that is all there is. Okay. All right. So hopefully this doesn't take us too long. What I wanted to do is look at kind of some real world data, and we can see, we could dig into this a little more and find more of a story. So this is the same polling period from the 2016 election and the 2020 election. And of course, you can see Clinton versus Trump for 2016 and Biden versus Trump for 2020. So the question I'm asking with this is, what does this graph tell you as a story? Like, what do you notice? Oh, and I should clarify what this is about. This is a favorability rating. So I think without context, it's going to be hard to say anything. Favorability means if 30% of the people say they like you and 50% say they don't like you and 20% have no opinion, then you're going to have a net favorability of -20, because it's your favorability minus your not favorable views. So 30% minus 50% gives you -20. So that would be this line right here. Any thoughts? So just maybe to clarify the question, in which race, 2016 or 2020, does the favorability between the two candidates seem to be more consistent?
The 2020 race.
Yeah, the 2020. There you go. And this was the same time period, like I said. So you've got kind of narrower favorability differences right here, and then it's spread out. And then this just kind of stays the same. This at the bottom is what you're going to be looking at in just a second. This is the, I think this is technically what they call net favorability. So when it's just a candidate, they call it favorability. But when we look between the two candidates, what we're going to do is it's always going to be the Democratic candidate minus the Republican one for this. So right here, -18 minus -25-ish gives us a difference of about 7. So right here, you can see the net favorability between the two is 7, which means at this point in time, Hillary Clinton had a 7-point favorability lead over Trump. And you can see that went down right here at the closest. It was less than 5. And then at the biggest, it was over, what is that, about 20 something. I don't know. Close to 20 there. So here's what I want you guys to do. I'm going to give you guys some data sets, and I want half of you, I'm going to put you in groups. Let me get out of this real quick. Okay, so this is the same thing. This is in the Canvas page. Down here, these are the favorability, the difference in favorability ratings for 2020. And here's the difference in 2016. All right, so what I want you to do, and this caused some confusion last semester. So all of these right here, left and right column, are 2016. I want you to create a list and create a box plot. So one of the groups is going to be for 2016. One of the groups is going to be for 2020. Does that make sense? And then we're going to come back. I'm going to have you guys draw those. So you'll need to get to your Canvas page so you can see the data. But I'm going to split you into your groups real quick, and you guys can work on this for, hopefully, I'll just check in with you guys, see if we'll start with like 5 or 6 minutes. And you'll probably need more time than that, but we'll see how much. But let's finish this up real quick. So anyone, maybe different people from the first group and from the second group, can plot where their mins and their maxes and Q1, Q3 median, where that was, and we can draw some box plots. So of course, I'll just draw a line right here to separate those two.